So, recursion in Python. What is recursion? A function calling itself is called as recursion. A function calling itself is called as recursion. A function can call another function that we know, but can a function call itself? Yes, function can call itself, and that is called as recursion. So, let us say, let's try to understand this concept by taking an example of finding a factorial of a number. We know that n factorial is equal to n into n minus 1 factorial. Okay. So, this is the factorial definition. By using this factorial definition, we will be writing a function, right. So, let us say this is a function factorial. To this function we will be passing the variable or this number, right. So, this is a doc string, right. Now, 5 factorial is equal to 5 into 4 factorial. This 4 factorial is equal to 4 into 3 factorial. This 3 factorial is equal to 3 into 2 factorial, and 2 factorial is equal to 2 into 1 factorial, and this 1 factorial is 1, right. This 1 factorial is 1, right. So, here as soon as I hit 1 factorial, I reach a dead end, that is called as terminating condition, right. This terminating condition in recursion is must. So, while expanding the recursion, we hit a dead end, right, and that dead end from that dead end will be starting winding up the recursion. So, this 1 factorial is a dead end. There I know what is the value of 1 factorial. 1 factorial is 1. So, I will be replacing that 1 factorial with 1. So, 2 into 1 is 2 now, and I will be returning this 2 as 2 factorial. 3 into 2 is 6. So, I will be returning that 6 as the value of 3 factorial. 4 into 6 is 24. I will be returning 24 as the value of 4 factorial. So, 24 into 5 is 120. That will be assigned to 5 factorial, or that is 5 factorial. So, that is how we compute factorial. Same concept we are using here, right. So, we are checking, is the number given to us 1? If that is, then I know the factorial of that number is 1. If that number is not 1, then I will be executing this. What is that? This formula. What is this? This n factorial is equal to n into n minus 1 factorial, right. So, this number into factorial of number minus 1. Now, we are calling this function factorial to compute the factorial of n minus 1. See, we will be calling this factorial number. So, that will be called to this function. In this function, we will check, is this number equal to 1? If it is not, then we will call the same function to compute the factorial of n minus 1, right. You see, this is a call to the same function from within the body of the same function. That means, this factorial function is calling. Who is the caller here? The caller is this factorial function, and to whom it is calling? It is calling to itself, right. So, that is called as recursion. A function factorial is calling itself with different parameter, of course, different value, right. In the beginning, so the call was for number, now the call is for number minus 1, num minus 1. So, let us see the execution of this, how it works, right. So, let us say I have, let me take another color here. Let us say we are calling this is a call to this factorial function. This is a call to this factorial function. First, this is the first call to this factorial number, factorial function. Let me write this call. So, factorial this 5, factorial 5. So, we will execute now, as we have a call, we will execute this factorial function. Now, here number is equal to 5, this number is getting a value 5. So, we will be executing this factorial function, right. So, in the factorial function I have this statement, right. So, if I separately write this, so return 1 if number is equal to 1, we are checking is if number is equal to 1, number is not 1. So, what we will what we are returning, we will not return 1, but we will return this, we will return will be returning 1 only if this number is equal to 1, else will be returning this num which is 5 into factorial of 4, right. So, before closing this bracket, and this bracket is the bracket of this return, before closing this bracket, right, this bracket, I will go to the factorial, I will execute the factorial function again. In fact, this is the second call to the factorial function. So, we are now going to factorial function again, we are executing the factorial function again, right. So, factorial, here num is equal to 4, right, we are passing 4 from here, right. We are executing the same function again, we are checking is number equal to 1, no, will not return 1 from here also, will not return 1 from here also. So, what will we return? We will return now num n is 4 here, num is this statement we are executing. So, 4 into factorial of 3. So, I have another call to the same function, but with parameter 3, right. So, I will be executing the same function with parameter 3 again, here num equal to 3, again in this factorial function I will check is num equal to 1, no. So, again I will return 3 into, I will be returning from here 3 into factorial of 2, right. That means, again I have a call to factorial of 2, I will be executing this factorial function again, and here I will be executing this statement else again, because num is not 1, num is 2 here, 2 into factorial of 1, right. Again I have a call to factorial function, I will be going to factorial function, I will be executing the factorial function again, and this time, this time number is equal to 1, number is 1. So, I find this condition true. So, I will be returning 1 from here. For the first time, I will be returning an actual value. So, I will be returning this 1, and this 1 will be returned to the previous call, right. So, this call was generated from this call, right. So, this 1 will be returned, and this 1 will be replacing this call. So, 1, and now from this call I will be returning 2 into 1, that is 2. So, this 2 will be returned to this call, right, and this 3 into 2, which is 6, which will be returned to this call. So, 6 into 4, 24 is written from here to this call. So, 24, and 24 into 5 is 120, that is written here, right. So, 120, and thus we get this statement factorial of 5 is 120. So, this was called expansion of the recursion, and as soon as we hit the dead end is the place where I know the value of the call, right, actual value. For example, I know the factorial of 1, as soon as I reach to that dead end, I know that value. So, I will be returning that actual value, and from that dead end we will be winding up the recursion, will be starting to wind up the recursion. So, dead end or terminating condition is very important in recursion, right. You expand the recursion, but you hit the dead end, and at that dead end you start winding up the recursion and come back to the, see, you have the first call, from that first call you generate many calls, you have not yet completed this call, you will first finish this call, then come back to this call and then complete this call, right. You will go to this call, you will complete this call and then come back to this call. So, this is called as winding up of the recursion. So, recursive recursive functions make the code look clean and elegant like this, right. So, you can write this by using non-recursive function, by using non-recursive way also, but recursion makes it more clean and elegant. Okay. Now, let us see the Python program to display the Fibonacci sequence up to nth term. So, what is Fibonacci sequence? The Fibonacci sequence is 0, 1, addition of these two 1, addition of these two is 2, addition of this 2 is 3, addition of these 2 is 5, addition of these 2 is 8, addition of these 2 is 13, and then addition of these 2 is 21, so on and so forth. So, this is a Fibonacci sequence. So, nth term in the sequence is equal to sum of previous two terms. nth term in the sequence is equal to sum of previous two terms, that is called as Fibonacci sequence. So, Fibonacci sequence or Fibonacci is again a classical example to learn recursion. So, here is this function Fibonacci. To this function we are passing this number. We want to compute the nth Fibonacci number. So, this is a recursive function to print Fibonacci sequence. We want to print a sequence till this n. So, what again, right? So, what is the terminating condition? We know that the terminating condition is if we are asked to compute the 0th Fibonacci number, that is 0, and first Fibonacci number is 1. These two are known to us. This is called as 0th Fibonacci number and this is called as first Fibonacci number. So, if someone asks us to compute the 0th Fibonacci number, we will return that number itself. If somebody asks to compute the first Fibonacci number, we will return 1 itself, right. That means, if someone asks to return the number, if someone asks to compute the Fibonacci sequence till number which is less than equal to 1, right, 0 or 1, we will return that same number. Else we will return this Fibonacci number is equal to this Fibonacci number plus this Fibonacci number, right. So, if somebody asks me to compute this Fibonacci number, I will be returning the sum of this Fibonacci number and this Fibonacci number. So, how will I compute this Fibonacci number? Using the same function, that is why Fibonacci of n minus 1. And how will I compute this Fibonacci number? Using the same function, right. That is why Fibonacci of n minus 2, right. So, I will be returning the n minus first Fibonacci number added with n minus second Fibonacci number as the nth Fibonacci number, right. So, you see here, if number is less than equal to 1, we will return the number itself, else we will be calling the same function, right. See, this is the only function which we have to compute the Fibonacci number, and in order to know the nth Fibonacci number, I must know n minus 1th Fibonacci number and n minus 2nd Fibonacci number, right. So, who will give me n minus 1th Fibonacci number? The same function, and that is why I will be calling the same function. And who will give me this n minus 2 Fibonacci number? The same function, that is why I will be calling the same function for computing n minus 2nd Fibonacci number, right. So, because we have this is the only function available at our disposal, let us say, to compute the Fibonacci number. So, I must know n minus 1th Fibonacci number. So, I will be calling this, right, with n minus 1 as parameter, and again the same with n minus 2 as parameter. So, if n is equal to 1, I will be returning the number, n is less than equal to 1, I will return the number, else I will be returning this the sum of the result returned by this function and this function. So, you see, if you pass, let me again show you, let me make this code little more clean so that we can understand this. Let us try to make this code little more clean. If num is less than equal to 1, so what will be I doing? If num is less than equal to 1, I will be saying return num, right. Else what will be I doing? I will be return this, right. So, let me execute this. Okay. So, now let us try to understand this code. Let me explain this code in a better way so that the concept of recursion will be very clear. So, let me number the statement. This is the only statement if else, right. So, I am calling this Fibonacci with n equal to 10, right. So, our call is Fibonacci of number, right, Fibonacci of number, and let us say eventually we at some point in time, let us say our number is equal to let us say 5. We want to compute the 5th Fibonacci number, right. I can call this function to compute the sequence till n. Okay. So, if I call, let us say Fibonacci of 5, let us say this is the call generated Fibonacci 5, right, somewhere. So, this here we are generating the calls. Fibonacci of 0 will return me this 0, Fibonacci of 1 will return me this 1, Fibonacci of 2 will return me this 1, right, Fibonacci of 3 will return me this 2, right. So Fibonacci 4, Fibonacci 5. So we are generating this call for number in the range n terms, right. So this will be this range will create a list from 0 to 0 to, let's say n terms is 10, so 0 to 9, 0 to 9, right. So we will be having the Fibonacci numbers. So this number will take this 0 value, 1 value, 2 value, so on and so forth. So we will be having we will be generating the calls Fibonacci 0, Fibonacci 1, Fibonacci 2, Fibonacci 3, so on and so forth, right. And let's say we are on this call called as Fibonacci 5. Fibonacci 5. Let's see how it executes. So when I have this Fibonacci 5, I execute this function. In this function, now here num is equal to 5. Num is equal to 5. We check, is num less than equal to 1? No, num is not less than equal to 1. We don't return this. We return this. That means I return from here. I return what I return? Fibonacci of num is 5. 5 minus 1 is 4 plus Fibonacci of 3. So this is the call to the same Fibonacci with parameter 4. So I'll be generating this call. I'll be going to this call where I'll be executing Fibonacci of 4. Now here num is equal to 4. We are calling the Fibonacci function, and to this Fibonacci we are passing this 4. That means num is equal to 4 here. So we will be executing this again. Is num equal to 1? We are executing this whole body of this Fibonacci here. Is num equal to 1 or less than equal to 1? No, we will be executing this again. So we will be saying return Fibonacci of 3 plus Fibonacci of 2, right. So we will be executing this Fibonacci of 3. So we have here fib of 3. So fib of 3 will generate 2 calls. Fib of fib means short form of this Fibonacci. Fib of 3, fib of 2, and fib of 1, right. So this fib of 2 will generate 2 calls, fib of 1 and fib of 0. As soon as I reach fib of 1, I will get 1. This will return 1 because here this condition will be satisfied. So from here I will be returning 1, and from here I will be returning 0, and here I am adding Fibonacci of 1 and 0. So from here I will be returning 1 plus 0 is 1. So I will be returning 1 from here, and this will be returning me 1, right. So from the fib of 3 will be 1 plus 1, 2. I will be returning 2 from here, right. So 2 from here. So this 2 will be replacing this 2, right. And this Fibonacci of 2, if I execute this will return me 1, and so this will be returning me 1. So 2 plus 1 is 3, right. I will be returning 3 from here as Fibonacci of 4, right. Fibonacci 0, Fibonacci 1, Fibonacci 2, Fibonacci 3, Fibonacci 4. So I will be returning 3 from here. So similarly, this call will return me 2, right, and then 3 plus 2 will be 5. That I will be returning as Fibonacci of 5. This answer, right. So expansion of the recursion. You see every call. How many calls we have here? We have Fibonacci 1, Fibonacci 2, Fibonacci of 3, and for Fibonacci 5 we have this big tree here. For Fibonacci 9 we will have a huge tree here, right. That means one call is generating many calls. That's the danger in recursion. We do lot of redundant computation. If you observe this tree, right, if I let me just draw a tree, right, how Fibonacci, let's see Fibonacci 9. We have this called Fibonacci 9. Short form I am writing for this Fibonacci. Fib 9 will generate 2 calls, Fib 8 and Fib 7. Fib 8 will generate 2 calls, Fib 7 and Fib 6. Fib 7 will generate 2 calls, Fib 6 and Fib 5, right. Again this Fib 7 will generate 2 calls, Fib 6 and Fib 5, so on and so forth, right. Now you see at the bottom, at the leaves of this tree, you will have only calls which will look Fib 1, Fib 0, Fib 1, Fib 0, Fib 1. This will be a huge tree, and And if you look at this tree, what are these? These are the function call. This is a function call. There we are actually executing this complete function, right? For this simple small line, we are actually executing this complete function, right? And you see, if you observe, we have fib 7 here, fib 7 here, fib 6 here, 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 and fib 1, fib 0 will be repeated enumerable, I mean, lot many times. So this is a redundant computation. We are doing the same thing again and again. Fib 5, fib 5, fib 5, fib 7, fib 7, right? So that's the danger of recursion. We will do, or we are doing, lot of redundant computation.